Hello and welcome to Math on the Go. We're going to be dealing with factoring quadratic equations. This video will cover quadratic equations with a leading coefficient of 1. And I am also making a second problem set that I'll link to up here, where we will deal with leading coefficients greater than 1. A quadratic equation is in the form of ax squared plus bx plus c equals 0, where a, b, and c can be any real number except a cannot equal 0. So with that in mind, let's get right to it. So we've got x squared plus 3x minus 4 equals 0. First thing we're going to do is we're going to make our parenthesis. We're going to put our x's in. Now just think back of when you were doing expanding, you had this set up and you got it to look like that. So now we're just reversing that order. So now that we've got our x's in there, we need two numbers that multiply to -4 but add to 3. So the only two numbers we've got are 4 and 1. So let's put 4 in here and 1 in here. Now let's figure out what sign we need. Well, we need it to multiply to be negative, so therefore we need a positive and a negative. And our 3 needs to be positive, so our larger number 4 needs to be positive, meaning our x is negative. And if you want to just double check something like this, you just do the FOIL method. So with that, you get x squared minus x plus 4x minus 4 equals 0, and then simplify that to x squared plus 3x minus 4 equals 0. So that's exactly what we had to begin with, so that's good. So this is set equal to 0, so what we want to do is we want to find the x-intercepts of these, or the roots. So what we're going to do is we're going to set x plus 4 equal to 0 and x minus 1 equal to 0 and solve for both. X plus 4 equals 0 and x minus 1 equals 0. That gives us x equals -4 and x equals 1. So that's our answer. The second example is x squared minus 9 equals 0. As you can see, looking at this, we can't factor anything out. We can't take an x out. We can't take a 3 out. We can't take a 9 out. So what we're doing here is a difference of squares. So that looks like this. We get our parenthesis, put our x's in, and a difference of squares gives us plus 3 minus 3. I'm not going to go through this step, but you're more than welcome to go ahead and double check that that's correct. And just like over here, what we're going to do now is we're going to set both x plus 3 and x minus 3 equal to 0. X plus 3 equals 0. X minus 3 equals 0. And just solve. X equals -3 and x equals 3. And those are our answers. This third example is pretty much like our first example, but it's given to us in a different way. Our 10x is on the other side. So all we really have to do is subtract off our 10x from both sides, which gives us x squared minus 10x plus 16 equals 0. So again, like before, set up our parenthesis, put our x's in. So we know 8 times 2 gives us 16, and 8 plus 2 would give us 10. In order to get a -10 and a positive 16, we need two negative signs in here. So 8 and 2 are both negative. And again, you can go through and solve, FOIL it out if you'd like to double check. But I'm just going to go with it because -8 minus 2 gives us -10. -8 times -2 gives us positive 16. So now again, just like before, we're solved for 0, or solved for x. It's -8 equals 0, x minus 2 equals 0, x equals 8, and x equals 2. Those are the few examples I wanted to cover in this first video featuring quadratic equations with the leading coefficient of 1. On the next video, like I said, I'll link to on the screen here right now, and I will have quadratic equations with a coefficient greater than 1. So I hope you found this video useful. If you did and you made it this far, please click that like button below. And I thank you very much for watching, and I'll see you next time.